G'day Year 7s, and here is our next video. I reckon I say that every time. But anyway, here's our next video. Exercise, we must be up to EF. Okay, exercise 5F here. And we're looking here at expanding brackets, which is also called, you see down here, the distributive law. So let's get straight into it, no mucking around. Okay, so few little notes sitting here. Expanding or eliminating. Alright, so expanding, when you expand the brackets, it actually gets rid of the brackets, so eliminates the brackets, that's why that's there. Involves writing an equivalent expression. We haven't really spoken about the equivalent expression. Basically it means an expression that means the same thing. Written a different way, but the same thing. So I might have something like x plus x minus 4, alright. That is the same as 2x minus 4. Okay, so they are equivalent expressions. Alright, so if whatever value I put in for x, it'll always give me the same answer for that same equation. So if the equations are identical, if they are equivalent, and whatever value I put in for the prime numeral, it'll always give me the same answer. Okay, so that's what equivalence means. And we might spend a little bit of time on that if we have time. All right, so brackets involves writing an equivalent fraction without the brackets. This can be done by writing the bracketed portion a number of times or by multiplying each term. So we'll look at this first one here by writing the bracketed portion a number of times. So if we've got here 2 times AB, remember that is a multiplication happening between those guys. Alright, and what I might do, so I'm just making this up as I go, I'll sort of try and be a little bit prepared. I'm just going to bring up this one for a sec. So if we've got, what is it, 2 and then A and B in brackets. Okay, let's do this one. If I did 2 times 4, what's another way I could write that? Alright, we know the answer is 8, but what's another way I can write this problem to get an answer of 8? Alright, and think about what we've got. 2 times 4, so 2 groups of 4. One group of 4 plus another group of 4. Alright, will equal 8. Okay, so we can do this the same way. So this is telling us, remember that's times happening between the 2 and the brackets. If there's nothing written there, there is a times. So we can do the same thing. Alright, so 2 times A plus B. So we could write A plus B once. Okay, and then plus, just like we have here, so that sort of represents the A plus B, the first part, then plus, and then A plus B again. Okay, so we could write it that way if we wanted to. So we've multiplied, done the same sort of thing, 2 groups of 4, so we've got 2 groups of A plus B. There's one group, there's 2 groups, add them together, collect our like terms, so A and A plus A gives us 2A, plus B plus B gives us 2B. Alright, so that's one way of doing it. Doing it that way. And there is also another way of doing it, which is called the distributive law. Okay, and doing it that way, bear with me 1 minute. Just want to get rid of this over here. Sorry, bear with me. I know this is just chewing up some time. Bit of elevator music happening at the moment. That'll do. Alright, so again, if we have 2A plus B, now what that is telling us is that everything inside these brackets, both the A and the B, have to be multiplied by 2. Okay, not just the A, but the A and the B. So the distributive law means that I can multiply that 2 by the A, and then I can multiply the 2 and the B together. And the way that looks like is, and this is the working out, this is the way I like to show it, 2 times A, then I write the plus B, and then I'm going to multiply that B by the 2 as well. So I'm multiplying the A by 2, and I'm multiplying the B by 2. Now sometimes some people will write it this way, and probably a lot of people will write it this way, plus 2 times B. But I do find a lot of students, particularly when there's a minus sitting in here, because sometimes you might get a minus number sitting at the front and you might get a minus sign instead of a plus sign in here, and I just find a lot of students get mixed up with that and make mistakes with their positives and negatives. So that's why I like keeping whatever's in the brackets together, like I have here. Alright, like I have here. okay, and then multiplied each of the parts within the brackets by 2 on either side. Alright, so I'm just going to get rid of this stuff. Alright, so our next step here is you put that together. So 2 times A, simply written as 2A, the plus just drops straight down, and then we've got B times 2, so the 2 number comes to the front, letter comes after, and look at that, we've got exactly the same answer. Alright, so that's one way of doing it. Alright, but I do suggest, and I think we will be looking at doing it this way, the distributive law, because that's what you'll be using more frequently, and you need to understand how that works. You can't, although this works in a simple problem like this, sometimes if you get a problem that looks something like this, for example, that becomes more problematic. Alright, and if you know how to do this way, then this process on this side actually transfers, and you can use it on a problem like that. Okay, alright, so there's one way. So writing the bracketed position a number of times, the bracketed portion a number of times, or using the distributive law. Alright, and to eliminate brackets you can use the distributive law, which states that, as I said, A times B and then A plus A times C, alright, or A times B and then minus the A times C, okay, in there. Alright, the process of removing brackets using the distributive law is called expansion, thus expanding brackets. Okay. When expanding, every term inside the bracket must be multiplied, and that's the important part. Every term inside the brackets must be multiplied by the term outside the brackets. Okay, so everything on the inside must be multiplied by the term outside the brackets, okay, which is what I showed you here, alright, in this part. Alright, let's go through some examples. Alright, expanding brackets by simplifying repeated terms. So repeat the expression that is inside the brackets and then collect like terms. The number outside the brackets is the number of repeats. So that's basically this first method that we just did, this one here. So I'll show you some examples of that, because obviously you're going to be getting questions that will ask you to do that, but this is the way we're going to focus on. But anyway, let's go. Alright, so 2 times A plus K. Now, actually, do my usual thing here. I want you to actually pause, because you've seen the example already where I've done it on this one. I want you to pause the video, and I want you to go and have a crack at both of these by yourself, and then come back and we'll check our answers. We'll compare. Alright, so please pause, off you go. Okay, hopefully you've paused. Welcome back. Again, you're not doing yourselves any favour if you haven't. So again, we're looking here at 2 groups of A plus K. So you should have had equals A plus K, there's one group, plus another A plus K. There's my second group. Group of like terms, A and A gives me 2A, plus K and K gives me 2K. Enter. Done. Really easy. Alright, let's have a look at this one. 3 groups of 2m plus 5. Alright, so 2, 3, in the brackets 2m plus 5, so 3 groups of 2m plus 5. So, follow our process. Remember, always follow the process. 2m plus 5, there's one group. Plus 2m plus 5, there's 2 groups. Plus 2m plus 5, there's 3 groups. Alright, collect our like terms. I've got my equal sign. Collect our like terms. We've got 2m, 2m and 2m, so that's 2, 4 and 6m. And 5 and 5 and 5, 5, 10 plus 15. Okay, really easy, really simple. Hopefully, as we've compared notes, that is the answers you've got. If you haven't, then maybe go back to the start and watch the things that we did at the start. Maybe watch this example again, just so you're clear, all right? But yeah, that's how we do it. 3 groups of 2m plus 5, that's what we've done. Collected our like terms, got our answer. Okay, really simple. All right, we're going to look at, and because there's some questions like this in the exercise, obviously, so we're going to look at these types of questions where we've got squares. All right, so what we're going to do is expanding brackets using rectangle areas. So we're going to write 2 equivalent expressions. Well, I'm not going to actually go to the equivalent part. I might on the first one, but I'm not going to go on the others. Okay, write 2 equivalent expressions for the area of each rectangle shown, only one of which includes brackets. Okay, so when you're writing this, what we're looking at is the area. Okay, so to find an area of a rectangle, what do we do? How do we find an area of a rectangle? If we've got a rectangle over here and we've got 5 and 2, for example, how do we find the area of a rectangle? Okay, hopefully you've said, well, area equals our length multiplied by our width. Alright, so that would be 2 times 5, which gives us 10. Okay, so you're multiplying these guys, the length and the width together, okay, to get your area inside. Okay, so this is going to be the same sort of deal. Alright, so if we look at our length times width, alright, let's nominate this side as our length. Okay, so that's 2 multiplied by, and what's our width? Okay, if we look at the big length of the rectangle here, our width there is 5 and x. Alright, so from here to there is 5, and then we've got x. So how are we going to show that? How are we actually going to show that length as being 5x? And this goes back to our exercise 5a, where you're trying to create an algebraic expression from some words. So how do you think that's going to look? So we've got 5, and how do we work out that length? Just say that length was 2. Just say that length was 1 sitting in here. Excuse me, was 1 sitting in here. Alright, what would you do? So that total length there, you'd say is 6. So you've done 5 plus 1 gives you the 6. Excuse me, throat's getting a bit dry. So we're going to do the same thing. We don't have 1, we've got x. So we're going to do 5 plus x. So 2 times 5 plus x. Now we're not just doing 2 times 5. We're doing 2 times, I am losing my voice, 2 times 5 plus x. Alright, so again that looks like that. Okay, and that's it. That's basically what we're going to do in terms of trying to create that problem, and then I could expand the brackets from that point if I wanted to. Alright, and if I did, I'd end up with which way we're going to do it. We'll do it the repeating way, so 5 plus x plus 5 plus x gives us 10 plus 2x. Alright, now ask for an equivalent way of doing it. Alright, so what we'll do is we'll look at each rectangle individually. So let's look at this rectangle first. So what's the area of that rectangle? Okay, which is 2 times 5. Okay, which is what I did over here. Okay, which equals 10. Now if we looked at this smaller rectangle, how do we find the area of that? Where we know this length is the same as this length on this side, so that's 2, and we've got x up here. So we've got 2 times x. And what's 2 times x? 2x. Alright, so if we wanted to then try and add these two areas together, so there's one area which is 10, that's 10 in there, okay, and this other area in here which is 2x, how would we find the total area? Yeah, hopefully you said well, you'd add them together, Mr. O'Donnell. You have 10 plus 2x, and look at that, same deal. Okay, exactly the same result you get out of that. Okay, so that we've just shown two equivalent expressions. That's one way of showing it, and this is another way of showing it, or this way. Okay, same thing. Okay, so they are equivalent expressions. If I whatever value I had for x, if I put in there, I'd get the same answer as if I put that value into that equation or this equation. Okay, all right. I'm going to clear a lot of this out, so just bear with me. I want to get rid of all that stuff. Geez, I've done a lot of drawing. Let's have a look at this second problem. I'm going to do the second one. I'm not going to do the third. Okay, so this problem here. Okay, same thing. Let's do it this way first. If we've, I better get rid of that one because you can't see the A. This is our rectangle. Length times width. Okay. Let's say my length is this one. So what's my length? Well, it's A and 3. So same deal as here. So it's going to be A plus 3 is going to be my length. Because remember, just say if I had said that length here is also, I'll just say it's 4. Whoops, geez, just lost everything. Just say that is 4 on that side. If I wanted to find that total length, I'd do 3 plus 4, which gives me 7. Okay, but I don't know what that value is for A. Alright, so instead of 3 plus 4, we're going to do the 3 plus A, or A plus 3. And then we multiply that by the 12. And remember, it's the whole lot. So we've got to multiply both the A and the 3, the A plus 3 by the 12. So again, to write that properly, we swing this part around to the front, and then we put our brackets after it. Okay, if I wanted to expand that out, a plus 3 and a plus 3, so I'd have 2a. Actually, I'd do that 12 times. What am I doing? Alright, so I'm going to do the distributive law here, actually. So if I do 12 times a, which gives me 12a, and then plus drops down, and then 12 times 3 in there, which is 12, 24, 36. Okay, if I wanted to do it the other way, I'd look at this rectangle first and do 12 times a like that, which gives me 12a, and then I'd look at this rectangle here, and remember this length is the same as this length, so that's 12, so 3 times 12, which gives me 36. And if I wanted to find the total area, I'd add those two together, which is 12a plus 36. Okay, same. Alright, so hopefully that makes sense to you. Alright, you're going to get some questions like that, and just think about how you label this length. Alright, when you've got a number and a letter, and remember, all you're doing is adding those guys together. Like I said, if that was a length of 1 in there, to get that total length, you'd do 5 plus 1, which would give you 6. Okay, but remember, we don't know what that is, so it's going to be 5 plus x, because we don't know what that value is. Alright, down to our last example here. So we're going to expand the following expressions using the distributive law. Alright, so let's get into this one properly, because this is the one I really want you to understand. Alright, so we've got 5 and then multiplied by, remember, so if you want to put a multiplication in there, do that if it helps you out. 5 times x plus 3, so we're going to multiply everything inside the brackets, the whole lot, by 5. Okay, so we're going to multiply the x by 5 first, and then the 3 by 5. So that's going to be our first one, that's going to be our second one. Okay, so we first want to do is 5 times x, then we do the plus 3, I like keeping that there, and then we're going to multiply that 3 by the 5 as well. Okay, so 5 times x first, and then the 3 times the 5, or the 5 times the 3. Alright, but I prefer to keep, like I said, these guys together, so we're not mucking around with these signs in the middle. Okay, so now we can write this out. 5 times x looks like 5x plus 3 times 5, which is 15. Okay, that's it. It's as far as you go. Let's have a look at this one. 8. A minus 4. Same deal. Alright, what I want you to do is pause this video. I want you to actually go and have a go at this now. If you want to go back and look at my previous example over on this side, have another look at it, work through it, and I want you to do this on your own. Okay, when you've done that, come back and we'll do our comparisons. Off you go. Alright, welcome back. Hopefully, again, not doing yourself any favours if you haven't gone off and done it on your own. Alright, so we're going to multiply the first part of the brackets by 8 first. So it's going to be 8 times a. Then we write the minus 4 multiplied by 8. Alright, so our thing outside the brackets is it's like our bookends. So this just drops down into the middle. Okay, we lose the brackets though. Please don't write the brackets in here. Okay, get rid of those brackets. We don't need to write them. That's why we said right at the very start, back here, okay, it eliminates the brackets. Alright, so when you do this, it eliminates the brackets. So make sure you do not write the brackets in there. You don't need to. Next thing, 8 times a, simply 8a, minus 4 times 8, which is 8, 16, 24, 32. So 8a minus 32. And that is it. We cannot go any further. We don't know what a is. So that is our answer. We can't go any further than that. Alright. Okay, so hopefully that made sense to you. I've gone through a few things. This is the one I really want you to make sure you understand how to do. These ones they look difficult, but they're not that difficult. Okay, you should be able to do them. If you want to know how to do this one, by all means ask me. I'm happy to, for those that want to challenge yourselves a little bit, have a crack at it and show me. Alright, come into class. Actually, I want some of you to do that. If you've got a good handle on this, or you reckon you have, I want you to try and have a go at, I've just given you a good hint there, haven't I? I want you to have a go at this one. Alright, this problem and come in and show me in class. All right, I'd be very impressed if I get a handful of you coming in, checking that one out with me. All right. Hopefully the rest of this makes sense. All right, it's not difficult stuff, but again, you've got to practice. Practice makes perfect, so make sure you practice, practice, practice. Any questions, come and see me. That's going to get you started on exercise 5F. One exercise to go, which is applying algebra. Yeah, go on and go forth and get it done. Thank you guys. Bye-bye.